Looking at 2 times e to the 6x minus 12, we have e to a power that's more than just a regular x. So I'm going to call that my u. U is going to be 6x minus 12. Now I'm going to take a regular derivative of that, du dx. The derivative of 6x is just 6. Derivative of negative 12 is 0. We're going to multiply by dx. So now I have my u is 6x minus 12, and the derivative of that du is 6 dx. Now I'm going to change my bounds. Looking at my old lower bound, it's 2, and my old upper bound is 4. And I'll plug in to the place that relates the u's and the x's. Always plug into u, never du. So u is going to be 6 times 2 minus 12, which is going to be 12 minus 12. So our new lower bound is 0. That is totally fine. It's usually nice to plug in 0 to things. So 6 times 4, my old upper bound, minus 12, because that's 24 minus 12, my new upper bound is 12. So now when I go to do this substitution, I'm really taking the integral from 0 to 12. And then I have e raised to the u for this one, which is awesome, because that's a nice integral to have to do. I don't even have to add 1 and divide by it, raise it as my new power. The integral of e to the u, it's just going to be e to the u. But before I can take that integral, I need to make sure I have my perfect du, which would be a 6 and a dx, but all I have is a 2 and a dx. So I have a 2 where I need a 6. So one way of doing it is thinking about how 2 is 1/3 of 6, or I can just make the inside 6. Maybe I'll do it the visual way. So if I want to make the inside 6, 3 times 2 is going to give me 6 dx on the inside, which is all going to be my perfect du. But in order to do that, I can't just triple it. I need to put a 1/3 outside to balance the fact that I need a 3 inside. So one way of saying it is 2 dx is 1/3 of my perfect du, or the other way is putting that 3 in there and the 1/3 outside, and then you have your du inside. Either way is fine. So now I'm ready to integrate. The antiderivative of e to the u is just e to the u plus k, or in this case, e to the u with an evaluation bar, from 0 to 12. So again, one way I could plug it in is 1/3 of e to the 12 minus 1/3 of e to the 0. I think that's the longer way of plugging in. So I'm going to plug it in as 1/3 of e to the 12th minus e to the 0, keeping that factor out front. That 1/3 can stay outside since it's applied to both terms. So e to the 12th I'm not so sure of, but I know e to the 0 is just 1. When I plug in the whole thing, though, I get 54,251.26381. It keeps going. So about 54,251. An exact answer, if you wanted to just leave it, would be 1/3, and you could leave it as e to the 12th minus e to the 0 is just 1. Here's an exact form. Or if you want to just round it, you could just say 54,251, maybe 0.3 or something like that. Round it to a certain decimal place if asked to round.